In this lesson, we will learn how to choose an appropriate sample size. When we are constructing an interval to estimate the true mean, sometimes we want to construct the interval with 90% confidence level or 95 or 98. Depending on the confidence level, we need a different sample size. To find how large the sample size should be, we're going to derive the formula. Remember that when we construct an interval, we're taking the point estimate, in this case sample mean, and add and subtract a margin of error to that sample mean, where margin of error is computed by taking the critical value z sub alpha over 2 and multiplying that by sigma over square root of n. To expand this same concept, we're saying here's my true mean I'm trying to estimate, and it will be somewhere between sample mean, my point estimate, minus the margin of error, and sample mean on the other end, plus the margin of error. Let's use letter m to represent the margin of error, which is z sub alpha over 2 times sigma over square root of the sample size n. This is what I'm trying to solve for. I want to know what expression will be giving me the right sample size. So pretty much at this point, I'm going to use some algebraic skills to solve this equation for n. First of all, let's pull square root of n out of the denominator, and we do that by multiplying both sides of my equation by square root of n. As I'm doing it on the right-hand side, square root of n I multiplied here will reduce with the square root of n I had there in the denominator previously, leaving me with z sub alpha over 2 times sigma on the right-hand side and square root of n times m on the left-hand side. Again, remember, my goal is to get n alone, so I'm going to remove m from there by dividing by m on both sides of the equation. Here, m over m reduces and leaves me with n under square root. Here it is. And on the other side, I have now a fraction, z sub alpha over 2 times sigma divided by m. Since I need to solve for n and not for square root of n, I need to remove the square root away from n somehow. To do that, I will square both sides of the equation. Square undoes the square root because these are inverse operators, and that leaves me with just n on the left hand side and z sub alpha over 2 times sigma over m all squared on the right hand side. Therefore, we derived our formula for the sample size n. Here is our example. A union of restaurant and food service workers would like to estimate the mean hourly wage mu of food service workers in the US. The union will choose a random sample of wages and then estimate mu using the mean of the sample. What is the minimum sample size needed in order for the union to be 95% confident that its estimate is within 0.40 of a dollar of mu? Suppose that the standard deviation of wages of food service workers in the US is about $2.15. Carry your intermediate computations to at least 3 decimal places and write your answer as a whole number and make sure that it is the minimum whole number that satisfies the requirement. First of all, I copied the formula. Sample size n is equal to critical value z sub alpha over 2 times sigma divided by m. Your sample size will depend on your confidence level because the size of this percent will impact your critical value. And also, the sample size will depend on how close of an estimate you want to make, so margin of error will have to impact this sample size, of course. Sigma remains same for this population no matter what confidence level we are looking for, and no matter what margin of error we are considering, this sigma will not change. 95% confidence level means I have 95% of data in the center and the remaining 5%, my alpha, is equally split between two tails. That's why we use alpha over 2 as a subscript here. And z sub 0.025 is the critical value that will separate the 95% of data in the center from the area in the tails. If you use inverse norm function, you can find z sub 0.025 to be 1.96. I highly recommend that you simply memorize the common critical values that come from 95% confidence or 90% confidence, 98% confidence, whatever common percentages we're using, they will show up very often. So just memorize them instead of computing them every time. All right, what else do I need to know? I need to know that the standard deviation is given to be 2.15, and of course point estimate is 40 hundredths. So I am recording that, and now I'm ready to use all of that information within the formula. Sample size n is equal to critical value 1.96 times a standard deviation of 2.15. Divide that product by margin of error of 40 hundredths, and don't forget to square this result when you're done computing it. Sample size n will be approximately equal to 110.986, and there are more digits that come after that. Please remember, as it is stated right here, make sure that it is the minimum whole number that satisfies this requirement. Therefore, whenever you are solving for the sample size, always round up to a whole number, not looking at the size of the digits. So the typical rounding rules should not be used here. Just remember to round up. For example, if you found sample size to be approximately 110.1, the fact that 1 is small doesn't mean you're going to round down to 110. You will still round to 111 wages because 110 of them is not enough. I need slightly more than that, which really means 111 is sufficient.